Welcome back. This is the second video for Unit 2 of Math 8. We were doing exponents and equations, and I'm going to move this out of the way. We are going to take over on the negative numbers. So, when we worked on this in class, what I showed you was what you know about exponents. And so I'm going to go ahead and just move on over to this side right over here, and then start what we talked about then, and then what I'm talking about with the happy and sad. So if you remember, we talked about how 3 squared means 3 times 3, which is 9. And if we had 3 cubed, that would mean 3 times 3 times 3, which is 27. And if we had 3 to the 4th, that would be 3 times 3 times 3 times 3, which is 81. Oops, sorry. And then we're looking at going in the other direction. So every time we add an exponent, or add a number to our exponent, we are multiplying by one additional 3. So to get from here to here, we multiply by 3. To get from here to here, we multiply by 3. So when we go backwards, what we're doing is dividing by 3. And then 27 divided by 3 is 9, which is why 3, which is to the first, is just 3. So we're dividing by 3, dividing by 3, dividing by 3. So if we divide 3 by 3, that equals 1, which is why anything to the 0th power is 1. All right, but let's keep going, because we can divide 1 by 3. So if we did 1 divided by 3, we would have 1/3. So since we're going down, this exponent would be to the negative first. And then if we divided by 3 again, that would become 1/9, and we go down another exponent, and we're down to -2. So the deal here is that negative exponents cause reciprocals. So we have the same exact value for 3 to the first as we do for 3 to the negative first, except we have the reciprocal. And we have the same value for 3 squared that we do for 3 to the negative second, except we have the reciprocal. So negative exponents cause reciprocals. So basically what this kind of led into was, as usual, me being goofy and saying that everybody wants to be happy. And we determine whether something is happy or not based on its exponent. Not based on the base number, but on the exponent. So if everybody deserves to be happy, then we need to change this 3. So basically what we need to do is move this number. And when we move the number to the denominator, or maybe we move the denominator to the numerator, we are then making that value happy. So that's how we kind of talked about with the happy and sad thing. So let's say we have 2 to the -5th. Well, this 2 is not happy, but we can make this 2 happy if we move it. And if we move it, now it's happy, so it's 2 to the 5th. And again, if there's something in the denominator, we never have 0 in the numerator just because nothing's written. It's an understood 1. Same thing can happen with variables. So let's say that we had m squared over n to the -3rd. So in this problem, let's look at each one separately. So starting with the m is happy, so we're going to leave the m in the numerator. The n is unhappy in the denominator, so what we can do is move the n to the numerator, and now it's happy. And again, when something is cleared in a fraction, it's not cleared to 0, it's cleared to 1. So, and then in that case, we don't need the 1 on that one. We do need the 1 on this problem. On this problem, the 1 is not necessary. So anytime you see negative exponents, that's just telling you to do the reciprocal. So just one more. Let's say we have, oh, who knows? Let's say we had 4 to the negative third. So this 4 is unhappy. Right now it's in the numerator. It's unhappy in the numerator. So we're going to make it happy by moving it to the denominator. And when we move it, now it's happy. That is filled in with a 1. And we know that 4 to the third is 4 times 4 times 4, which is 64. So we can go ahead and simplify that one completely. Now, on the milestone, it is possible to have multiple answers on some of the questions. So this might be one of those problems where, you know, maybe they give you this, and they give you this, and they give you that. All 3 of those are the same thing. So just watch out for those questions if it says that you can choose more than one possible answer as being correct, because if this was the problem, both of those answers are correct. So just keep an eye out for that. All right, let's continue with the exponent rules. So we learned 3 major rules of exponents. One is when we're multiplying, one is when we're dividing, and then one is when an exponent has an exponent. So let's start off at the top. And again, if you need to pause the video to get all of the information filled in, then please do. So if the bases are the same when multiplying, we add the exponents together. So let's say we had m to the third and we're multiplying it by m to the fifth. That is going to end up being, if we had m to the third, that would be m. And m to the fifth would be m. So a shortcut is, instead of writing all this out and then counting, why don't we just add the exponents together? We have 8 m's multiplied together. Because remember that an exponent is repeated multiplication. So we've already multiplied 3 together right here. We've multiplied 5 m's together here. So when we're done, we're going to have multiplied 8 m's together. So when you multiply and the bases are the same, you add the exponents together. Notice that the m didn't change. So let's say we had 2 to the 7th times 2 to the negative 2nd. All right, so we know the shortcut. We could change this like we did up here, but I think it's easier to do the shortcut. We know we're multiplying a bunch of 2's together. We multiplied 7 2's together, but then we divided by 2 2's. So in the end, we multiplied by 5 2's. And then you can simplify that. That would be 32. So again, notice that the base number did not change, just the exponent. All right, the next rule that we learned was when dividing, we're going to subtract the exponent. So this is the same idea. It's just that we're dividing instead of multiplying. So how about we have k to the third over k to the fifth. All right, so 2 ways we could think about it. To write it out, k to the third means that we multiplied 3 k's together. K to the fifth means we multiplied 5 k's together. So we know that when we have fractions, we can cancel, reduce, simplify, whatever you want to call it, and we can cancel those also. So now what we're left with is k squared in the denominator. And again, when we clear everything in a fraction, we don't clear it down to 0, we clear it to 1. All right, well, let's see if subtracting them would have worked. Had we just subtracted these from the beginning, we would have done 3 minus 5. And 3 minus 5 would have been k to the negative 2nd. And k to the negative 2nd is not happy. So if this is over 1, then we know we need to move this k to the denominator. And now the k is happy. And again, we always replace with a 1. So we ended up getting the same thing. So this one works. If you subtract exponents, you will get the right answer. That's if you're dividing. All right, let's try one more of those because you have to make sure you subtract correctly. So let's say we had m4 over m to the negative third. All right, so we know we don't have to write all this out. We can just subtract the exponents. So we need to subtract 4 minus negative 3. Well, 4 minus negative 3 means 4 plus 3, so this would be m to the 7th. So the shortcut is to avoid doing all of that stuff right there and to avoid doing all of that stuff right there. The shortcut is multiply with the same base. You're going to add the exponents together, divide with the same base, and you're going to subtract the exponents. But remember, you're subtracting the top one minus the bottom, even if it's negative. Okay? Last one for the rules. Whoops. If an exponent has an exponent, then we're multiplying the exponents together. So this one looks different because there's only one base number. So this is only one base. Okay, so this would look like this. If we had 3 squared to the 5th. All right, basically this rule right here is just a condensed version of this rule up here. But if we wanted to, we need to multiply 3 to the 2nd 5 times. So that means 3 to the 2nd, 3 to the 2nd, 3 to the 2nd, 3 to the 2nd, 3 to the 2nd. And then, since we're multiplying, we'd add all those together and we'd get 10. Well, definitely an easier way to do that would have been to just multiply the 2 times 5. So when the base number has an exponent and then that whole set has an exponent, you're going to notice it because it will have parentheses. But when you have that situation, that's when you multiply. Same thing with variables. So let's say we had p to the 7th to the 6th power. Well, golly, who wants to write all those out? That's just 42 of them. So it makes it a lot easier to know the shortcuts that you can use with exponents. Okay, I think that is going to be the end of this video just for time. So I am going to do a third video which covers the last 3 topics of Unit 2.